Silence stretches across the black expanse of space. A silence so deep it almost feels alive. Then a distant pulse flickers, faint as the heartbeat of a sleeping giant. One by one, NASA's telescopes align toward that glimmer, tracing the coordinates of an object humanity has watched for months. 3IATLAS. When the first image appears on the data screens inside the Jet Propulsion Laboratory, it looks ordinary, a bright speck against the dark. But as software filters peel away the static, something begins to take shape. The tail of the object, once thought to be gas and dust, curves inward, forming a ring of light that seems to feed back into itself. The glow is not uniform. It pulses, rhythmically, as if the object itself were breathing. The wavelengths match nothing in NASA's comet database. Carbon dioxide? Frozen water? Not likely. Instead, sensors record sudden bursts of electromagnetic radiation, the kind normally seen near pulsars, not comets. A quiet murmur ripples through the control room. One scientist leans forward, whispering, "That's not reflection. That's emission." And for the first time since 3IATLAS was discovered, the data suggests something impossible. This object is not just reacting to sunlight, it might be generating energy of its own. For decades, interstellar objects were only a theory, a mathematical possibility scribbled on whiteboards and tucked inside astrophysics journals. Astronomers believed that debris from other star systems must occasionally pass through ours, but none had ever been observed directly. Then in 2017, everything changed. The first visitor, Oumuamua, flashed across our solar system, spinning like a flattened shard of metal, vanishing before any spacecraft could chase it. That single event redefined the limits of planetary science. Now, a second traveler has arrived, designated 3IATLAS. It was first spotted by the Asteroid Terrestrial Impact Last Alert System, ATLAS, a network of telescopes in Hawaii designed not for wonder, but for warning. On an April night, the system flagged a faint object moving against the background of distant stars. At first, it looked like a comet, following an arcing path toward the sun. But even early images hinted at something different. The tail glowed too brightly, its chemistry too unstable. NASA, ESA, and observatories worldwide scrambled to gather data before the object moved out of range. The Hubble Space Telescope, the James Webb Space Telescope, and ground-based instruments in Chile and Spain all focused on one target. Over the next weeks, the data streams grew dense. Infrared readings, chemical spectra, trajectory models. Yet nothing fit the standard profiles of known celestial bodies. The object was accelerating in strange bursts, not consistently, as if something internal were influencing its motion. Dr. Eleanor Voss, a spectroscopist at NASA's Goddard Space Flight Center, described the pattern in one of her early briefings. "It's as if the object exhales," she said. "You see this rhythmic ejection of material, but it doesn't behave like sublimating ice. It's something more structured." Her words echoed across scientific circles, drawing comparisons to phenomena seen around magnetars, stars whose magnetic fields could crush iron. But 3IATLAS was far too small, far too cold to belong to that category. To understand it, NASA formed a joint research effort with the European Southern Observatory and the Planetary Defense Coordination Office. They combined telescope arrays from 3 continents, creating one synchronized network. For the first time, humanity could observe an interstellar visitor in near real time. Its rotation, its emissions, even its thermal heartbeat. Each passing day brought sharper images and deeper confusion. What began as a comet classification quickly fractured into debate. Was this a rock, a remnant, or something engineered by nature in ways we had never imagined? Meanwhile, the object continued its steady plunge toward the inner solar system. By mid-September, 3IATLAS had crossed Mars's orbital plane, leaving behind a shimmering trail visible even in amateur telescopes. Its surface reflected light inconsistently, alternating between matte black and mirror-bright white, as though different materials covered its spinning form. That alternating pattern produced electrical readings no comet had ever shown. Instruments detected faint electromagnetic oscillations, measurable, structured, and repeating every 7 minutes and 49 seconds. To most people, it was just another scientific curiosity. But within NASA, those signals became the focus of sleepless nights. The data did not merely suggest chemical reactions. It hinted at a controlled process, one that seemed to regulate itself. Every cycle of light and radiation appeared deliberate, patterned, as if the object itself was maintaining balance against the forces of space. And then came the transmission, the new image, filtered and enhanced through Webb's mid-infrared array. What scientists saw would change everything they thought they knew about 3IATLAS. The image transmitted from the James Webb Space Telescope arrived as a compressed data stream, more than 200 megabytes of filtered infrared light. Engineers at the Space Telescope Science Institute ran the first decryption overnight, converting spectral noise into color. When the file finally rendered on screen, it silenced an entire control room. Against the deep amber haze of solar reflection, the object appeared not as a diffuse cometary blur, but as a defined structure, elongated, luminous along its equator, and framed by a faint halo of blue-green radiation. At first glance, the halo looked like ordinary coma gas, but further spectral analysis proved otherwise. The wavelengths clustered near 8.6 microns, too low for water ice, too high for silicate dust. Instead, the emission matched traces of ionized carbon chains known as polywines, molecules that form only under intense ultraviolet bombardment. These same chains had been detected in Titan's upper atmosphere and in the cold clouds where stars are born. Somehow, 3IATLAS carried those building blocks in open space, unprotected yet intact. Dr. Voss and her team overlaid the spectra on a rotation map. As the object spun, the emission peaks rose and fell like breathing cycles, every 7 minutes 49 seconds, exactly matching the electromagnetic oscillations detected earlier. That synchronization stunned the analysts. Natural outgassing was random, but this rhythm was precise. It suggested internal resonance, a feedback loop between surface chemistry and magnetic field. In other words, the object wasn't venting, it was stabilizing itself. But when researchers stretched the image contrast beyond safe calibration, faint concentric ripples emerged around the halo, 5 distinct rings expanding through the surrounding plasma. Each ring moved outward at equal velocity, implying continuous energy discharge rather than sporadic eruptions. The mathematics resembled acoustic patterns, standing waves frozen in space. Nothing of that sort had ever been seen around a comet or asteroid. NASA's heliophysics division ran a magnetohydrodynamic simulation using the observed field strength. The results were absurd. If 3IATLAS maintained that oscillation autonomously, its magnetic moment would equal that of a small moon. That power could not come from frozen gas alone. Something inside the object was converting solar energy into electromagnetic motion, a process closer to induction than reflection. In Pasadena, technicians cross-checked data from ESA's solar orbiter. The orbiter's instruments had caught secondary flashes at the same coordinates, short ultraviolet bursts coinciding with each magnetic pulse. The pulses propagated outward, intersecting the solar wind and then curling back, like tides reversing direction. For every burst emitted, an echo returned, subtle, delayed by 212 seconds, as if the space around the object were responding. Those echoes weren't noise, they carried structure. Spectrographic layering showed fine spikes repeating at mathematical intervals, prime number spacing, a pattern never produced by random plasma turbulence. Prime intervals occur naturally only in quantum resonance or deliberately tuned systems. The finding triggered internal debate. Could this be harmonic coupling or an artifact of instrument overlap? Yet multiple observatories confirmed the same modulation. The team initiated continuous monitoring. Every rotation, 3IATLAS flashed across 3 frequency bands: infrared, radio, and soft X-ray. The synchronization among those bands indicated cross-field coupling, meaning the emissions were linked by design, not coincidence. Each sequence formed a triplet: flash, pause, flash. Some scientists compared it to Morse timing, though no one dared call it communication. The safe term became coherent resonance. As days passed, The object brightened beyond prediction. Sunlight alone couldn't explain it. Photometric readings showed energy output increasing as it approached the sun, the opposite of a comet that sheds mass and dims. The surface temperature remained stable at 210 Kelvin, suggesting a self-regulating cooling mechanism. Each burst of light was followed by a dip in infrared heat, as though the object vented energy to control its own balance. Within NASA's data servers, algorithms compared 3IATLAS to every known comet, asteroid, and interstellar fragment. The closest match came from no natural catalog. Instead, the signatures resembled laboratory plasmoids, small containments of magnetized plasma created by humans to study fusion stability. Those artificial structures lasted seconds. 3IATLAS had maintained its pattern for months. The new James Webb composite added one more anomaly: geometry. Zoomed images showed that the object's tail was not a random stream, but a tight spiral of ionized gas, coiling around a central axis like a magnetic tether. Each coil was separated by exactly 1/600 kilometers, matching the intervals of its magnetic waves. The entire shape looked engineered by physics itself, ordered yet chaotic, organic yet geometric. Journalists caught wind of the story after an internal memo leaked from the Planetary Defense Office. Headlines called it the living comet. NASA issued a measured statement, neither confirming nor denying the reports. Officially, they described the object as an interstellar body exhibiting non-standard electromagnetic activity. Unofficially, researchers stopped calling it a comet at all. As October approached, 3IATLAS entered its closest approach to the Sun. Spacecraft from multiple agencies prepared for coronal interference, expecting the object to evaporate like others before it. Instead, the plasma around it tightened, compressing into a luminous shell that repelled solar wind particles like a magnetic shield. Cameras on the solar orbiter recorded the moment in ultraviolet light. A brilliant flare burst outward and then folded back, forming a ring of light larger than Mercury's orbit. For a few seconds, the sun's own corona dimmed around it. Sensors saturated, then went dark. When data streams resumed, the object was still there, intact, bright, and drifting away from the sun as if pushed by its own radiation. In the silence of space, 3IATLAS had survived a solar encounter that should have destroyed any known comet. NASA summed up the moment in a single sentence during its press briefing. Energy is not just leaving this object, it's reorganizing around it. For the first time, the agency admitted that 3IATLAS might represent a class of interstellar matter never observed before. A phenomenon that doesn't fit within the categories of comet, asteroid, or meteor. Something else entirely. As 3IATLAS drifted outward from the sun, it should have faded. Instead, its brightness intensified. Solar radiation pressure, which normally pushes debris away, appeared to draw light toward the object's axis. Photometric data showed a standing corona, steady, luminous, and rotating opposite to its trajectory. It behaved as if gravity itself had bent the laws of thermodynamics for a single traveler. Weeks after perihelion, the Parker Solar Probe passed through the outer edges of the object's electromagnetic field. Sensors recorded abrupt voltage surges, forcing the spacecraft into safe mode. When systems came back online, the probe had captured 3 seconds of magnetic waveform, unlike any previously observed, coherent, layered, harmonic. In that brief window, Parker had effectively heard the pulse of 3IATLAS. The waveform contained symmetry. FFT analysis showed mirrored frequencies on either side of a central node, like 2 instruments tuning to the same pitch. Natural magnetic turbulence never mirrors itself so precisely. It implied interaction, a resonance between internal and external fields, almost as if the object were listening to its own echo. Ground observatories confirmed a faint secondary emission following each Parker reading. Low-frequency radio bursts repeating every 8 hours. They arrived sequentially across the globe, each station receiving the signal moments apart due to Earth's rotation. The phase timing was flawless, so consistent that even milliseconds of deviation were measurable. No random process sustains that accuracy across days. NASA's Deep Space Network triangulated the source. The bursts originated from within a 5-kilometer zone surrounding the object, not from the sun or interplanetary medium. That ruled out reflection. The emission was self-generated and directed, its beam width narrowing slightly with each cycle, as if focusing. Within the radio band lay modulation, encoded shifts resembling information density. Though no one could decipher it, spectral compression hinted at deliberate packaging of energy. The pattern repeated exactly 216 times before resetting, as if each sequence were a full rotation or event cycle. Inside laboratories, scientists replayed the composite signal through sonification algorithms. The sound was haunting, low hums rising into rhythmic crescendos ending in silence. Some described it as a heartbeat, others as mechanical wind. But its mathematical consistency defied poetic explanation. It was data rendered audible. Meanwhile, the James Webb Telescope tracked visual fluctuations across multiple wavelengths. Every radio emission coincided with a brief spectral inversion. Regions that had glowed bright turned dark, and vice versa. The surface of 3IATLAS seemed to oscillate between absorption and reflection, almost like a mirror flipping its polarization. ESA's solar orbiter captured the most astonishing frame, an ultraviolet flash expanding in a perfect sphere, then collapsing back into the object without ejecting material. The entire event lasted 0.4 seconds, releasing more ultraviolet energy than a small flare. Yet instruments detected zero mass loss. Whatever process powered it was clean, contained, and repeatable. For planetary scientists, containment meant control. Nature rarely creates processes that vent nothing. Each ejection, each fusion, each collapse releases fragments or radiation tails. Here, the energy cycled inward. The implication was staggering. 3IATLAS wasn't merely stable. It was self-regulating, using physics we didn't yet understand. Theorists proposed that the object might possess a plasma envelope, functioning like a superconductive shell, converting solar particles into organized current loops. If true, it could represent a naturally occurring form of magnetic confinement, something humanity has been chasing for decades in fusion research. Others urged caution. Similar excitement surrounded Oumuamua, until models explained its acceleration through hydrogen outgassing. But in this case, no chemical fit the data. Even skeptics admitted that the magnetic resonance, prime interval pulses, and self-containment presented a trio of anomalies impossible to dismiss as coincidence. By late October, 3IATLAS had crossed Earth's orbital path, still glowing, its tail compressed into a tight spiral. Amateur astronomers photographed it from backyard telescopes, sending images that matched Webb's. Same geometry, same rhythmic flicker. For the first time, civilians could witness a phenomenon that blurred the boundary between comet and something entirely new. Then, a final image arrived. Using Webb's high-gain sensor, NASA captured a multispectral composite just before the object moved beyond optimal range. In the processed frame, the halo displayed faint linear striations converging toward a single luminous node. Every strand of light pointed inward, not outward, as if energy were collapsing into its core. No one could explain the physics, but every scientist in the control room felt the same unspoken realization. They were watching something evolve. The object's activity wasn't fading, it was organizing. Inside NASA's Goddard Space Flight Center, the conference room glowed with the faint blue of multiple projection screens. Graphs scrolled continuously, luminosity curves, radio spectra, temperature plots. The numbers refused to behave. Every model that assumed a simple cometary origin broke apart under the new data. What remained was an outline of something the scientific vocabulary struggled to define. Dr. Eleanor Voss stood at the front, marker in hand, translating equations into shapes. "Energy isn't escaping," she said. "It's circulating." She drew a spiral, one side feeding the other, an endless loop of motion. To her, the reading suggested a magnetically confined plasma envelope, a structure capable of maintaining internal order without solid boundaries. If correct, 3IATLAS might represent the first naturally occurring fusion equilibrium observed in open space. ESA analysts cross-referenced the data with information from Jupiter's magnetosphere. Similar resonant loops existed around Io's plasma torus, but those required the planet's immense magnetic field. 3IATLAS was operating alone, far from any stabilizing body. That independence fascinated plasma physicists. A self-contained field of that magnitude would require a mechanism comparable to a miniature dynamo. Essentially, a magnetic heart. The object's heart showed rhythm in chemistry as well as magnetism. Spectrometers aboard Webb detected fluctuating emission lines of carbon, oxygen, and sulfur repeating in the same cadence as the magnetic pulses. Each cycle produced transient molecules that vanished within seconds. Chemical creation and annihilation perfectly synchronized with field oscillation, a harmony never seen in comet physics. Dr. Voss compared the spectrum to laboratory fusion experiments, specifically Z-pinch confinement rings where plasma compresses into luminous filaments. The resemblance was uncanny. Even the energy ratios, light to heat, magnetic to kinetic, matched scaled projections from fusion tests. "It's like the universe is showing us the equation solved," she remarked quietly during one closed session. Her statement was later redacted from public transcripts at the European Space Operations Center. Theoretician Dr. Anja Morel proposed an alternative. Perhaps, she suggested, the object wasn't generating fusion, but stabilizing chemical recombination through magnetic scaffolding, essentially a naturally grown reactor of frozen and ionized gases that harvests solar energy to maintain equilibrium. In that sense, 3IATLAS could represent a transitional form between comet and protoplanet, a stage never before captured. Skeptics pushed back. They argued instrumentation artifacts could mimic resonance. Cosmic rays, sensor feedback, even algorithmic smoothing might create artificial symmetry. To settle the issue, NASA's High-Energy Astrophysics Division reprocessed the raw data manually. No filters, no corrections. The pattern survived. Prime number intervals, electromagnetic harmonics, photometric pulses, all real. The skepticism turned into uneasy fascination. Within that data, analysts found a temporal drift. Every 24 hours, the signal's baseline advanced by 1.3 seconds. That slow drift implied internal rotation separate from its visible spin, as though an unseen core turned within the envelope. If confirmed, it would mark the first evidence of nested rotation inside an interstellar object. NASA issued a formal classification proposal. Interstellar Plasma Body Class, Y, 3IATLAS. The term avoided sensationalism yet acknowledged uniqueness. In press briefings, officials emphasized the object's scientific value rather than mystery, framing it as a window into cosmic processes that might explain how magnetic order arises from chaos. But among researchers, the quiet question persisted. If it's organizing itself, to what end? As debates intensified, Dr. Morel presented a historical analogy. She displayed spectrographs of Earth's early atmosphere, taken from deep rock isotope studies. The ratio of carbon to sulfur emissions mirrored the patterns now seen in 3IATLAS. "It's chemistry that learns stability," she said. "Exactly the chemistry that preceded life." The room fell silent. A frozen echo of our own beginnings might now be gliding between the stars. In the months that followed, the story of 3IATLAS spread beyond the scientific community. Universities, private observatories, and even amateur networks coordinated nightly tracking. The object's steady pulse became a symbol of precision itself, a cosmic metronome beating across millions of kilometers. For NASA, it was no longer just an anomaly. It had become a reference point, a new constant for measuring cosmic stability. Engineers at Caltech modeled its internal field dynamics using supercomputer arrays normally reserved for fusion simulations. They expected chaos. Instead, their models converged. Every iteration produced an identical equilibrium state. The algorithms even predicted that the object could survive near-Sun encounters indefinitely by redistributing absorbed radiation along magnetic lines. "It's not breaking the laws of physics," one researcher noted. "It's simply using all of them at once when the models were reversed, simulating energy flow backward. The pattern still held. That meant its system was reversible, lossless and theoretically infinite in operation." No natural process behaves that way, except superconductors at near absolute zero. Yet this was happening in open space at hundreds of Kelvin. The finding hinted at a form of matter that might conduct magnetic energy without resistance. An interstellar-scale superconductor born from cosmic evolution. ESA's plasma physicists began to reconsider how interstellar chemistry works. Perhaps the void between stars isn't empty, but seeded with precursors of magnetic cohesion, the same structures that later formed nebulae, suns, and eventually life-bearing planets. 3IATLAS could represent a bridge between molecular clouds and star formation, showing the moment when raw elements learn to cooperate through magnetism. Across the Atlantic, NASA's astrobiology division found something even more striking. Deep in the object's emission spectra lay faint traces of nitriles, carbon-nitrogen compounds fundamental to prebiotic chemistry. These molecules are fragile, easily destroyed by radiation, yet they persisted around 3IATLAS, shielded by its magnetic envelope. The discovery reignited the oldest scientific question: can life's ingredients assemble not on planets, but in deep space itself? Within those nitrile traces was a ratio, 1:618 to 1, the golden proportion recurring in natural systems from spiral galaxies to DNA helices. Coincidence or cosmic pattern, no one could say. But its presence hinted at geometry underlying chemistry, suggesting that order might not just emerge from chaos, but be embedded within the universe's blueprint. By winter, international agencies agreed to classify 3IATLAS as a protected observational object. No impactor missions, no active probes, only passive study. The object had become a natural laboratory, a celestial archive of processes older than our solar system. Some researchers half-jokingly called it the teacher, believing it could instruct humanity on energy balance and stability more eloquently than any textbook equation. NASA's Director of Astrophysics summarized the situation before Congress. "We are witnessing matter organize itself in defiance of entropy," she said. "If this is natural, it means stability is more common in the universe than chaos. If it's not, then something made it, and that too is a discovery." Her words echoed through every headline the next morning. The following week, ESA released an updated orbital map showing that the object's trajectory had changed slightly, a deviation of less than 1%, yet mathematically significant. The course shift suggested that 3IATLAS had subtly adjusted its orientation after its solar encounter. The change matched the timing of its magnetic pulses, as though those oscillations doubled as propulsion. For a brief moment, one dataset from the Webb telescope showed a luminous filament detaching from the object, a thin ribbon of plasma drifting outward, curling and then dissolving. Analysts described it as an energy molt. Whether accidental or intentional, the emission carried its same harmonic signature, as if the object had shed a fragment of its own magnetic skin by early December. 3IATLAS began fading beyond the range of most optical telescopes. Its light dimmed, not because it died, but because it receded into distance. Yet radio antennas still caught faint pulses, slower now, gentler, like the last chords of a cosmic symphony fading into silence. Before transmission loss, one final measurement arrived from NASA's Deep Space Network, a low-frequency wave pattern matching Earth's Schumann resonance, the natural electromagnetic heartbeat of our own planet. Whether coincidence or resonance through space plasma, it was as if, for one brief moment, Earth and 3IATLAS had vibrated in tune. The signal ended there. The monitors went dark. Scientists stared at the quiet screens, aware that they had glimpsed something that might take decades, perhaps lifetimes, to fully understand in the end. What remains of 3IATLAS is not its brightness, but its silence. The pulses have softened into background static, blending with cosmic microwave noise, a faint rhythm woven into the fabric of the universe. Somewhere out there, the object continues its journey, carrying within it the memory of a solar encounter, and the curiosity of a species still trying to understand what it truly saw. Scientists cataloged the data, archived the signals, and turned their telescopes toward new coordinates. Yet something about 3IATLAS lingered, an unfinished equation, a whisper between physics and philosophy. It reminded them that discovery is rarely about answers. It is about recognition, the moment when the unknown looks back and in its reflection, we see our own search for meaning. The 8 words, Dr. Voss, in her final briefing before the mission wound down, described the experience not as observation but as participation. "We didn't just witness a phenomenon," she said. "We interacted with it. Every photon we measured, every frequency we parsed, altered how we define life, energy, and motion." Her words became the closing line of the official NASA report. To observe is to change. To understand is to belong. The echoes of that sentiment reached beyond laboratories. Artists painted its glowing spiral. Poets wrote about its heartbeat. For the public, 3IATLAS became a reminder that even in an age of technology, wonder is still our oldest instrument. We measure the cosmos not only with equations but with awe, the quiet language that predates science and survives it. The final archived image, enhanced months later, revealed something almost poetic, a faint reflection of sunlight shaped not like a tail, but like a wave. It looked as though the object had left a signature, a trace curling back toward the sun, folding light the way memory folds time. Perhaps coincidence, perhaps design. Either way, it closed the story like punctuation written in starlight. And so 3IATLAS drifts onward, beyond our reach, leaving behind only questions precise enough to matter and mysteries large enough to inspire. It may be centuries before another interstellar traveler crosses our sky. But when it does, humanity will look up again, wiser, quieter, ready to listen to the language of the void, because somewhere between science and story lies the simple truth of discovery, that the universe is not a riddle to be solved, but a relationship to be continued. 3IATLAS taught us that even the coldest objects can carry warmth, and even silence can speak. In its light, we are reminded that curiosity is not a question, it is an inheritance. It is an inheritance.